This will be our first video in the set of Chapter 11 videos. Chapter 11 of our text is Inheritance and Polymorphism. There is a lot to talk about here. We kind of take a step back into object-oriented programming, as we did in Chapter 9 and 10, and just understand some more object-oriented programming concepts, which are inheritance, polymorphism, the super keyword, overriding, overloading. We're going to take a look at the equals method, and then discuss the difference between static polymorphism and dynamic polymorphism. So there's a lot to discuss here, and with that, I am going to not go through the entire PowerPoint at once. I'm going to instead go through the beginning, show you some examples, and then go through the next part, show you some examples, and just keep that up. So let's start. This is the agenda. We will probably just discuss inheritance, and then I'll show you some examples, and then we'll do the same for super. So inheritance, what and why? Object-oriented programming allows us to define new classes from existing classes. This is called inheritance. So we've made files where we had multiple files talking together, right? Like we've made an animal client, and then we can make many animals based on it. We've made a musician client where we can make many musicians based on it. But inheritance is a little different than that. It takes it one step further. Inheritance is an important and powerful feature of reusing software. So the classes that we've made so far, they are reusable. They do eliminate a lot of redundancy, but inheritance allows for something called a superclass and a subclass, or a parent and child class. So let's take a look at exactly what that means. Why would we do this? Super and subclasses. You can use a class to model objects of the same or similar type. Different classes may have some common properties or behaviors, but also they may differ. You can define a more specialized class to inherit the properties and methods from a general class. So still a little bit confusing. What exactly does this mean? Here are some examples. So if you think of a person generally will talk, walk, and eat, right? Those are three pretty defining things that most people do: talk, walk, and eat. Well, we can say that a math teacher, well, they probably teach math, right? That's their job. But they also talk, walk, and eat because they're a person. And a football player, they play football. That's their job. But they're a person, so they talk, walk, and eat. And a businessman, well, runs a business or works for a business, but they are a person, so they talk, walk, and eat. Imagine if I told you to make a class for each of these people: a math teacher, a footballer, and a businessman. Are you going to say that the math teacher teaches math and talks, walks, and eats? Are you going to say that the footballer plays football and talks, walks, and eats? Are you going to say the businessman works for a business and talks, walks, and eats? Well, it seems very redundant to have them all talk, walk, and eat when we can just have this super, or this parent class called person, right? Because they are all a person, or they are all people, we can simply say that all of these people talk, walk, and eat. They all inherit the person class. So teach maths, play football, run business are all children of the parent person. That way, we don't have to say each one of these. We don't have to define the methods of talk, walk, and eat in each one of these. We can simply inherit it from their superclass. So let's look at another example, an animal. So a Labrador, a Greyhound, a Tabby, and a Manx, what they all have in common is they are animals. Now a dog and a cat are two different types of animals, right? But they are both inherited from the super animal class. And the hierarchy here is more than just the two-level here. It has a three-level hierarchy. So we can say a Labrador is a dog, and a Greyhound is a dog. Greyhound and Labrador inherit from the dog class, and the dog class inherits from the animal class. So everything a Greyhound can do, a dog can do, or everything an animal can do, a dog can do, and everything a dog can do, a Greyhound can do. Everything an animal can do, a cat can do, and everything a cat can do, a tabby can do. So instead of redefining things as you go down the hierarchy, you say the subclass can do everything its parent class can do, and more stuff. So here is another one, an even more in-depth example of vehicles. So we can say we have vehicles as our superclass at the top of the chain right here. But if we pick any of these, for example, at random, a bus is a vehicle, a van is a vehicle, a sports car is a vehicle, a motorbike, vehicle. They all inherit the vehicle superclass. There are some different categories, right? So a heavy truck is a truck, but it's also a vehicle. An estate car is a car, but it's also a vehicle. A motorbike is a bike, but also a vehicle. So you can see the chain of command right here. So motivations, suppose you will define a class to model circles, rectangles, and triangles. These classes have many common features, right? If you think of shapes, shapes have many common features. What is the best way to design this? Would you make several classes? Well, probably, because they're all different shapes, but they would all inherit from the geometric object shape. Although a circle and a rectangle are very, very different shapes, they are both geometric objects, so they both will have certain features such as the date they were created, the color they are filled in, if they are filled in or not, how to print them, but of course they would have different features as well, like number of sides. Circle will have radius, and rectangle will have 4 sides. How many sides will circle have? Will rectangle have a perimeter? Will circle have a perimeter? So some things are defined only within circle, and some things are defined only within rectangle. But the things that they share in common are that they are both geometric objects. So instead of rewriting the code in circle and rectangle, they can inherit from that super or that parent class. So a couple of notes on inheritance that we need to be careful about. Despite the name subclass, a subclass is not a subset of a superclass. In fact, a subclass usually contains more information and methods than its subclass. Thinking about this, when you think of the word subclass, you think it would be lesser than the superclass, right? Because it's a subclass. The opposite is actually true. Because a subclass is derived from a superclass, it can do everything the superclass can do, and more. So subclasses can actually do more than the inherited superclass. Private data fields, data encapsulation, like we've spoken about before through chapters 9 and 10, are not accessible outside of their class. Therefore, they cannot directly be used in a subclass, but using accessor or mutator methods, better known to us as setters and getters, we can change and update data there. Be careful when you extend. Think first, is it necessary? Do I need to use inheritance here? For example, a square should not be inherited from a rectangle because width and height are not appropriate here. A square would extend to geometric object class. So don't just inherit for the sake of it. Think, does it make sense? Am I going to need some of these methods? Do they have much in common enough to cause inheritance? This kind of says the same thing, but for different reasons. Don't inherit just for the sake of reusing methods, right? Don't just say, oh, there's a couple of methods that this class has that I need from that class. Don't do that because, for example, a tree and a human share things in common, right? Trees have a height and an age, and so do humans. But one should not extend the other. I shouldn't say inherit this tree from this human, or that human from this tree, just because they both have age and height. Inheritance would be very misused here, so be careful of that. Java only allows you to derive from one class. You can only extend from one class, meaning you can only have one level of inheritance directly. So be careful what you choose. That kind of sums all of this together. We are next going to do this example, inheritance example, called sports team.